Hey guys, it's Chili here. Welcome back to Hardware 3D. I'm excited today because we're going to be setting forth on a whole new leg of our journey. And I call this leg the ass leg for reasons that will become clear very shortly. Now, the medium-term goal, the goal of this leg is to be able to load and render models and scenes. You know, up until now, we've been basically just coding up loops and stuff to generate basic geometry. And you know what? That is starting to make me just die. My soul is dying from that. I don't want to do it anymore. And it's also not typical in a real game. You're not going to do that very often. Mostly, you're going to be loading assets from models files. And another reason why we want to do this is because it is going to look slamming. And it's also going to provide motivation for us to explore new parts of the API and new graphics techniques, like, for example, normal mapping. And we're also going to see, quite big changes to our drawable, bindable system as we tweak it and we refine it to better suit the workflow of loading our models. Now, they say a picture is worth 1,000 words. Take a look at this. This is what we are going to be aiming for. One of the things that we're going to be aiming for. This is actually from an engine made by a very prolific community member called SlidyBat, and he's also writing his own engine in DirectX 11. So, and I look at some of this stuff and I say, that's pretty sweet. Let's do that. This is called the Sponza scene. This is called the nanosuit. And we are going to be working towards loading and rendering these and other things that look sexy. Now, the name of the library that we're going to be using is called Open Asset Importer Library, or Assimp. And now you understand why I named the tutorial arc the way I did. So we're going to be using this, and the reason why is there's lots of reasons. First of all, let's take a look at the GitHub page. It supports a buttload of formats, and that is very convenient for us. It's also highly popular, and that means that when we run into problems, it'll be a lot easier to Google solutions to those problems. It supports like a bunch of things like post-processing of models that you load. That makes our life a lot easier. And it's got sort of good documentation. It has documentation, at least. Don't know if you'd qualify it as great, but it is existent, and that is better than most. Last but not least, the name is it's very on brand for me. So, that's important. Now, before we jump right into the code, we have to have the talk. The binary compatibility talk. And you should already be sort of aware of this issue if you watched my video on COM, but we're going to add this library in, and it is not going to statically link to our code like, say, for example, imGUI. It is going to be referenced from our executable as a DLL. Now, there are a few ways that you can go about doing this. Now, the easiest way you can think of doing this is just acquire the DLL from somewhere and copy that file into your project folder. And as long as the DLL was built with a compiler that is compatible with your current compiler, that will work. Now, I didn't want to do this because, I could find a DLL, or I could make one and copy it into the project and put that on GitHub. But then when someone else clones the solution, and they're using a different compiler, they're not going to be compatible with this DLL, and it's going to cause problems. They're going to have to grab their own version of the DLL. So I considered other options. My favorite option for this is, instead of copying the DLL, you use something called a package manager. And my favorite one is, VC package for this sort of thing. And then when you have a project that needs Assimp, in VC package, you just pull in Assimp. You pull in Assimp, and then your project will depend on it globally. Any project that you have on your computer will depend on that global Assimp that was built on your machine from source code. So I could use that, and then when anyone else clones my project, they would also have to use VC package and grab it. And that's a very clean way of doing it. But the problem is that then you guys have to have VC package. And I know from experience that some people have, problems working with VC package. They don't understand it. They mess up some of the steps. And that makes my life more difficult because then they come to me saying, Chili, it don't work. So I don't want to use VC package. Even though I'm using it on my machine, I don't want to use it for this tutorial. Now, the other way that we could do it, and this is by some measures the best way, is in your solution you have multiple projects. So you'd have one project that builds your exe. And then you have another project that, let's say, builds a DLL. So you could add Assimp as a sub-project of your solution. And then when you build your solution, it builds the DLL and it builds the exe with a dependency on the DLL. And then everything is all in the solution. The problem is that Assimp is very much a CMake project with a lot of custom build steps and bullshit and dynamically generated source code that basically makes it impossible for me to make it a sub-project in the Visual Studio solution. Now, ultimately, the option that I decided to go with was option number 1, which is basically make the DLL on my machine and then copy it in here and just commit that binary to GitHub. And then you guys will get that same binary. This one is going to be built using the compiler that comes with Visual Studio 2017. And the good news is that Visual Studio, since version, I think, 2015, has committed to a certain level of backwards compatibility, meaning that a binary built by a lower version of the compiler will be able to be consumed by a higher version of the compiler. The reverse is not true. If I build it with 2019, I couldn't use a 2017 compiler and expect it to work. But this means that this should work for 2017, 2019, and probably future versions as well. But if it doesn't, you should at least be aware of this issue. Be aware of the fact that the binary is basically just copied in there. And if you're having problems, you might have to acquire a binary that is compatible with your compiler version and copy it in. Replace the one that's in the actual GitHub. That's for any of you watching this, in the fairly distant future. All right, enough with the foreplay. Let's get down to the changes. So, looking at my history here, added Assimp. So when I work with a new API, SDK or whatever, what I like to do is the first thing I like to do is just try to integrate the SDK, and without even accessing any of the code, just try to add it to the project and see if I can get things to build without error. And I did that, and it worked. And once you can get that done, the next step is just to make a very minimal call to the API and see if it A, builds, and B, actually works at runtime without any errors. And when I did that, I found that it worked with error. Here's the DLL that I copied in, Assimp DLL. I got this by building it with the VC package on my machine. I should actually talk about this, I guess. There are multiple ways you can acquire a binary. One way is to clone the project and build it with CMake or whatever, or generate a Visual Studio project and then build that. That would be kind of a pain in the dick. Another way that you can do it is they actually have a download here. You can see here, go to download page, and I think that's just on GitHub. That's a release here. And for Windows, it gives you an SDK setup execute here, but that'll install it on your machine. I haven't done that, so I don't know where things go or how they're accessed. You would have to figure that out on your own. I mean, you don't have to, because the thing is in the project already. It's on GitHub. You don't have to do any of this. But if you were, in a separate project, you wanted to incorporate Assimp, this is one of the ways you could do it. The other way is the way I did it, which is, I used VC package. Search for Assimp, found Assimp, and then you could, run the command to install Assimp, and everyone would be happy. But like I said, the binary that is required is already in the project for us, so you don't have to do that. And then you have to copy in also the header files. Those will be needed for our project. Now, when I first incorporated and I made a function call, I got a runtime error, and that was that it also needed zlib. So I copied that in as well. So both of those are in here. The headers are in here. And once that was done, another thing I realized was that it was going to be a big pain in the ass to support binaries for both 32-bit and 64-bit versions of this bullshit. So what I did was I nixed the 32-bit configurations. Because do we need these? No, we don't actually need them. They were just there from the beginning. I didn't see a reason to delete them. But now that I have a reason to delete them, because I don't want to do extra work, I'm going to jump on that and I'm going to delete those bastards. And once I got that working, the next step was just to make a simple, well, I told you already, I made a simple call to the API. And what I did, you have to include these header files, and you create an instance of the importer, and you go imp read file, and I tried to load Suzanne.object with some options here. We'll talk about these in a second. And that's it. I just called it and made sure that it runs and it works. I am just now getting a sinking feeling because I added Suzanne to the project, but it's not in here. And I think I know why. And that is because Visual Studio adds object files to the files that should be ignored because, you know, they're binary intermediates. They shouldn't be committed to the repo. But the Wavefront file format also uses .obj, and that's annoying because now this didn't actually get committed to the freaking repository, and that's going to make my life harder. See, in the actual folder here, I've got models and I've got Nanosuit and Suzanne, but obviously those bastards are being ignored. So here's the culprit, git ignore, right here, this line. Now we can see if we comment that line out, save that, and we look in at our git kraken, automatically Nanosuit and Suzanne appear. But we still want to ignore object files. We just don't want to ignore object files that are in the models directory. So I uncomment that line and my boy's gone. All right. Now, after this line here, we say, but don't ignore stuff that is in models. Don't ignore object files if they are in models. And if we do this, we will see it didn't work. And the reason for that is because the root is here. So we've actually got to go one level deeper into HW3D. So if I do HW3D/models star.obj, save that, look at my git, beautiful, everything is in here, stage that, commit it, beautiful, new commit here. Now we've got all these other changes. This is now a different branch, but we want this whole history on top of this change. So what I'm going to do is I am going to switch this one. I'm going to rebase dev26 on top of here, and that's going to replay all those commits on top of there. Then I'm going to put the work in progress on top of here. So I'm going to pop it and stash it again. Now this branch here is redundant, so we're going to delete that. Yeah. And there we go. So now we have rewritten history. Add Assimp is in there right here. And then let's check out this commit again back here. Okay, so now we have the models committed into there, and that should be good for you guys. Yeah, whatever. Beautiful. So like I was saying before, we were so rudely interrupted. We added the binaries, we added the headers, added a little bit of test code that is going to load one of our models. And when we build and run it, we get our little engine, our little test scene here as we've had it before. Nothing really changed. It's just, it's calling a little bit of code from Assimp when it runs is all. But it's not using that code to do anything interesting. So that is the next step. Now that we verified that we can call code from the SDK, let's use it to do something at least verifiable. So look at the next commit. We don't have to talk about that. We saw it live. We're doing it live. The next one here is we add another drawable, I think, to our system. And we call it the as test. And it inherits some test object as usual. But its constructor is a little different because it doesn't call our geometry generating bullshits. It loads the geometry from a model using Assimp. So let's check this out and take a look at the code because it'll look better if we don't have it in that window there. We get all a nice code highlighting, syntax highlighting, all that good stuff. So drawable, as test. This is fine. We don't need to look at this. Okay, here we're getting into the good stuff. So not static initialized, and we're going to load the model statically. So all of the drawables are going to share the same model. Like I showed you, we create the importer and we call read file on the file with some options. We'll take a look at these options in a little second, but let's just take a look at the general workflow of loading a single mesh. So once you've loaded the read file, it returns something called a Assimp scene. And I just name it a model because it's basically a model. But I guess a scene could technically comprise multiple independent models. anyways, we got a model. Now, a model can consist of a number of meshes. So in the model, you have an array of meshes. And we're just assuming that there's going to be a mesh 0 here. We're not doing any checking or anything because we know we're loading a single, we know what's in this file. So we get a pointer to that mesh, and then we load the vertices and we load the indices. So if you look at a mesh here, we can see it has a number of methods and directly accessible properties. And one of those guys is the number of vertices. So we loop through all the vertices and we just access them by index. So we have m vertices, which is an array of vertices. So we access a vertex, and from that we have the x, the y, and the z. We use that to create the position vector. Also note that I multiply each one of these components by a scale, a floating point number that is, I believe, passed in. Yeah, it's passed in the constructor here. It just allows me to control the size of the model in the overall scene. So we scale it down a bit, I believe. And the other one here is loading normals as a float 3, and we just do that by basically casting, reinterpreting that, whatever this is. It's AI vector 3D, and we're just reinterpreting that as an XM float 3 because their layouts are identical, and it works. I'm not sure why I didn't do that. Oh, I know why I didn't do that for this one, because I wanted to scale it. So I had to do a processing in between there. But yeah, very simple to load the vertices. Indices, a little more tricky, but not that hard. A mesh consists of a number of vertices, number of indices, and has a number of faces. So every face or every polygon has a number of indices, and each one of these indices references into your array of vertices. Now, we told Assimp to triangulate. So that means if this model happened to contain any quadrilaterals or any higher order polygons, it should break them down into simple triangles. So that means that all of our faces have exactly 3 indices. So we can, up front, we can reserve the space in our index container, number of faces times 3, and that will be the number of indices that we need total. And then we loop through all of our faces. I just make a little alias here to make the code a little neater. And the first thing I do is I do a little sanity check. I make sure that all of the faces actually have 3 indices. They should all be triangles because we triangulated it. And once we get that, we do the face, and we look into index 0, push that back, index 1, push that back, index 2 in the face, and there you go. You've just loaded your first model, and it wasn't actually super complicated. Well, I wouldn't say a first model, our first mesh anyways. Although in this case, the model and the mesh are one and the same. But anyways, the rest here doesn't need any introduction. You guys are already familiar with this construct here from the previous tutorial. So if I run this, we should meet Suzanne, and we haven't seen her for a while. So it'll be a nice reunion here. Check it out. Let me get a better camera position in here on the action. And yeah, we can see Suzanne here being rendered. We can see the specular is working just fine. Oh yeah, it's looking great. Added a little bit of a green material color here for your viewing pleasure. No problems. Works awesome in our existing system. All right, now as promised, let's take a look at these flags here for the read file function. So if we search one of them on Google, get this thing here, and we can see, I don't know, there's a bunch of macros. Here is the enumeration of the types, and they seem to all be fairly decently, documented, maybe. I think these ones up here are just, these macros are just different configurations, pre-built stacks of flags that you can use for various scenarios, max quality, fast, convert to left-handed, etc. But anyways, let's see if we can't find triangulate. Here we go. Triangulate all faces of all meshes. By default, imported mesh data might contain faces with more than 3 indices. So it's like I told you. Now, if we remove this, I don't think we will have any problems. And the reason why is because I imagine that model to already have been triangulated, but I might be wrong. So let's run it. And it works. So that means that wasn't strictly necessary for this particular model. Now what about this one? Join identical vertices. So what it seems to be saying here, is if this flag is not specified, no vertices are referenced by more than one face and no index buffer is required for rendering. So basically, by default, what Assimp will output, regardless of the model format, is it'll output independent vertices, all independent. So all triangles will have unique vertices, which is useful for certain situations. But usually, you're going to want to do indexed and you're going to want to join triangles that share an identical vertex. You want them to actually reference the same vertex. So let's do a little experiment here. We're going to run this and we're going to see how many vertices we have when we run it with this flag enabled. So we can see right here by mousing over, num vertices is 7830. Now let's get rid of this option here. We're not going to join identical vertices and we're going to run it again. Oh my, apparently it does not have a default parameter for the flags, which is dumb. I don't approve of it, but anyways, run that with the flags of 0. And what we get for the num vertices is now we get 46464. So maybe seven times as many vertices as we had before. That's a lot of vertices. So here, indexes are actually redundant because every one of these is unique, but it'll still work. It should still work, I believe. Let's run it, see if it works. Yeah, it still works. It's just using way more data than it needs to. So yeah, putting this flag in here saves us a lot of stuff and it makes our indexed rendering actually mean something. But this is very interesting because remember before with my drawable bindable system with the geometry, when I wanted to create a mesh that had smooth shading, I had to write one function, but then I had to write a completely different function if I wanted to have a mesh with flat shading because then it needed to have independent faces. But with this here, with one flag, you can get one or the other. It's so beautiful. I love it. But that's going to about do it for today. We've still got a lot of work to do. With Assimp, we're going to learn how to load more complex models with, hierarchies of nodes and movable pieces and instantiation, all that good stuff. But in the next video, we're going to take a little bit of a detour, one video, and we're going to look at something that I don't often deal with, and that is some template meta programming bullshit. It's going to be interesting. It's going to tie into what we're doing here. But until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button, helps a lot. And I will see you soon with some more Hardware 3D.